What's great at this point of the course is you actually understand what's on this piece of paper now that I have in front of you. Differentiation we've been doing for a couple months now. What's nice to see about problems like differentiation, which I know we usually say dy dx, they're basically taking the y and replacing it with some function, whether it be x or ax or x to the n, and continuing from there. I do notice that starting with number 4, they say the derivative of cosine is negative sine. I know we had a mnemonic device to remember that. What was the trig ladder? All right, and as you went down that trig ladder, you could do derivatives. 6 through 8, we didn't really cover too much in our class, except maybe through some extra credits, second marking period. You might have had to use 1 or 2 of those. But 10 and 11, we definitely needed to know, and number 12. We don't really use 13 through 15 too much. So now you should understand what this is saying. These are sentences saying the derivative of a function is, and then whatever the answer is. So officially, I'd say in the last 2 weeks, we've started to look at integration. So the only thing I'm noticing here is they are kind of missing one of my favorite statements about the integral of a number times a function dx. You can actually take the a out before you integrate. It just does try to make it easier for you. So I think that one's missing, but in a sense, we've been doing the integration of 1 as being x, and the integration of a was ax. Now they are mentioning this a, so we should really denote what a is too. In all of these formulas, what would a be a number of? Complex numbers, or are we breaking it up either real or imaginary? And if I would say real, and then from real, do we need to go into any of the subsets there? I don't think so. I think as long as we're using a real number, we're good. For instance, let's not forget something as simple as number 2. In the differentiation, the derivative of, let's say we want to take the derivative of pi x. Of course, the answer would have just been pi. So that's still using number 2 there. So you are using any real number, rational or irrational. So back to integration, I will say 4th and 5, you are going backwards on this trig ladder. 6 through 9, we probably won't be using like 13 through 15 too much, but 10 through 12 is what I wanted you to be practicing now, and that'll be coming up in our next. So here we want to find the average velocity of a rational function. So we know that 1 over b minus a times the integration from a to b of a function dx is the average value of its function from a to b. So we can set this one up as 1 over 5 times the integration from 1 to 6 of this function. So this function, I see a 10 in front of 1 over 3 minus 8x because I want to take that 10 out and just concentrate on integrating 1 over 3 minus 8x. So as I take out the 1/5 that's already there, as I take out the 10, I am integrating 1 over 3 minus 8x dx. So if we do go back and look at, let's say, number 10 in this integration statement column, you can see there the integration of 1 over x is the ln of the absolute value of x plus c. So that's where in the explanation, I'm just going to go right to here, you can see the 1/5 and the 10 are in the explanation down here, and the integration of 1 over 3 minus 8x, they're writing as the ln of the absolute value of 3 minus 8x, but they're also multiplying by negative 1 over 8 because this entire statement is the function that if you take the derivative of it, you would get 1 over 3 minus 8x. So you really needed that extra negative 1/8 to make sure that the derivative of this function, we'll call it capital F, its derivative is this function, little f. So that -1/8 is a little hard to remember. Always test what you write as your integration, and if you take its derivative and get what you wanted to get, then you will be correct. So this all cleans up to a statement that then they basically follow some pre-calculus skills to simplify, and we could talk about that next.